So hello everyone, in this tutorial we are going to make this awesome node tree with geometry nodes in Blender 3.0. So this node tree deform any mesh surface according to the shape of the caustic that we want. For example, in this case I want the shape of the caustic like this little heart. So when the light shine on this surface, it focus that light in this form of heart on this object. So it has many applications, like you can 3D print these objects with some secret message. So when someone shine light on this, it's going to reveal that message in the form of caustics. So in this tutorial we're going to do that for the polished metal or for the reflection caustics. So in my coming tutorial we will do that for the transparent material like glass or the refraction caustics. For the visualization of these acoustics, I am using LuxCore render engine. So it is free render engine and you can download this from this GitHub page. Just download this latest build and which works fine on Blender 3.0. So download this according to your operating system and install this zip file as a regular add-on in Blender. So let's get started. Okay, let's delete this cube. So first let's add this plane. So the idea is, suppose we have this light source and we want to focus the light from this source on this point. So when light shine on this surface, it should focus on this single point, not like that. Okay. So for that we have to convert this shape into like a parabola, something like this, and this is our focus. So here is the light source. So when now light shine on this parabola, it focus on this point. So the distance of this point is denoted like f, and this is the focus of this parabola, and this is the z-axis, and in this is the x-axis. So the formula to offset these points of this mesh point along this z-axis is given by this parabola. Formula is z is equal to x minus h over the square over 4f. So what is h is, suppose our focus is not at the center of this mesh, it is somewhere here. So to account for that, so this is the offset. Okay, so now let's do this in the geometry nodes. Okay, another thing is we have to subdivide this plane, because this to get accurate caustics or sharp caustics we need a lot of subdivisions. So let's subdivide this plane. Okay, now first we need is a set position node, and then we need the position of the vertices that we want to offset. Next is the XYZ combine and XYZ separate node. So let's connect this to this, and this to XY, and this to the position. So now we have to offset this Z scale, okay, based on this formula. So let's write this formula. Add math node, then duplicate it. So first is x minus h, so then we need to square it, change this to multiply, and here is 4f, and we want to divide this x minus h squares by 4f. So let's make a group for this, and this is our focus, which is f, and I'm going to rename the inputs and rename this as 1D parabola. Now if we connect this X to the value, and for our focus, let me hide these formulas. Okay, so let's add empty for our focus. Scale this down. Let's put it somewhere here. So let's bring that empty, and we want the z-axis of this empty, z position. So let's connect this to the focus, and now because our empty is at the center of this mesh, so offset is 0. So now if I connect this to z-axis, we can see that our mesh is deformed according to this focus. Okay, but if I move this focus along the x-axis, we can see that our shape doesn't update. Why? Because we haven't connected this z offset of this empty to our offset of the parabola. So let's connect this to this. Now our shape is correctly deforming according to the position of the focus. Now if we go to the third 3D view, we have also y-axis, but our shape doesn't take into account the deformation from this y-axis. So to do that, just duplicate this and connect y to this value and offset this y offset to this offset, and now we're going to combine this using a math node. Let's add them and now connect this to the z. Now we can see that our shape is deformed according to both the x and y. So let's group this. So I'm going to rename that the second input as offset, which was on x and y axis, and our focus is at z axis, and rename this as 2D parabola. So now we have this, and now let's visualize this. So first we need, let's move this into somewhere here. So let's add a plane at that empty location so that we can see the caustics, something like this. And now go to this render setting and change the render engine to Lux Core. So it also provides this render setting helper. So click on this, and we don't want the cycle settings. CD, our scene is outdoor. Caustic in the scene, yes. In the mirror, yes. So change this path to bidirectional. So bidirectional means it is shooting light from the light source as well as from the camera. So other setting going to the same, just choose the halt setting for your rendering, means either the sample or based on the time. Okay, also you can use the threshold value. So now let's add material to this. I'm going to add this Disney material, show the nodes. Let me go to the shading. So change this metallic to 1 and roughness to 0. And for our screen, I'm going to rename this as screen. So for the screen, we're going to use Disney material with some dark texture, so we can see that reflection clearly. So now if we go to the render view, we see nothing because we don't have a sunlight. So let's add the sun. And now if we go to the render view, we can see that all the lights rays are focused on this plane. If there is not enough caustic, just increase this gain, so you're going to get more bright acoustics. Now we have our parabolic mirror with one focus. Okay, let me hide the sun. Now let's bring our explanation. Okay, now what we want is, we don't want the light to focus on single point, we want the light should focus on a shape. So let's add a shape. Suppose we want to focus a light on this shape, and this is the surface. So the idea is, first we scatter a uniform point on this shape like so, and then we're going to project this point on this surface, and based on the proximity of this point, we're going to select some area on this surface, and this area going to focus the light for this point. Means when light shine on this surface, it going to focus for this point. Okay, and similarly other point, we project this point on this surface and select the area, and this light this area going to focus the light for this point. Okay, something like this, and so on for the other points as well. So let's add our shape. For the caustics, I'm going to use this Bezier circle, something like this, and let's bring that circle in our node tree. So change this to relative, and first we're going to resample this for the uniform points based on this length, and then we're going to change this to curve to mesh, because the proximity node doesn't take into curve input, so we need to change this to mesh. Now for the projection, we're going to use first a raycast node, and then we're going to use the proximity node. So why is that? Suppose if our mesh is something like this, and this is the shape for the caustics, and if we scatter these points on this shape, and this point going to get more area on this surface because it is closer to this mesh, and these points get less area. So the best thing is we project these points onto this surface and then use the proximity node. And second thing is, suppose if we have situation something like this, and this is shape is not at the center of this mesh, so then the point which are closer to this mesh going to select this area, not the whole mesh. So to overcome this problem, we have to first project this shape at the center of this mesh and then use the proximity node. So that's why projection is important before the proximity. So for the target geometry, let's disconnect this, and for the target geometry we use our plane, and for the source position we're going to need the position of the points. And now if I use set position node for this curve, and this is the position, so if I join this, we can see that our curve is projected on this mesh. And if I move this Bezier circle means along the x-axis, we can see that when it is at the edge of this mesh, it doesn't project correctly. The reason for this is that we are using the ray direction directly in this direction, but we have to use the rays for the world center. So to do that, let's add the math node and subtract the position of this shape from 0, so that is the direction for the world center, then connect to the redirection. Now you can see that our circle is at the center. So that is the reason we need first recast with the proper direction before the proximity. So now we have our projected points on the surface. Now let's use the proximity node, and based on the points and for the position, we need the position of the vertices. Now we get the position of the these circles or the circle points based on the proximity. So each mesh vertex get its closest circle point. So we have same number of circle points as the number of vertices. So you can see that if I put this position into the set position of this mesh, the whole mesh going to collapse on this circle. See, but we don't want the position of those circle points. We want it is index, so that we can get our original points of the circle which is not projected on this mesh. So that way we can get it is x, y, z and also the focus. So let's add the transfer node, and then we need this integer because our index is integer, and for the geometry is this projected curve, and we want nearest, and this source position is the points of that circle based on this proximity. So now we get their indices, or now get the position of the original curve which is not projected on this geometry. So let's change this to vector because we are transferring the position, and based on the index which is this, and our target is the original circle which is not projected. Now if we bring our this 2D parabola, and let's disconnect this our empty, and let's connect this as offset and focus, and then connect this to position. And if I bring this circle close to this surface, so you can see that the whole mesh is deformed according to this shape. Means when light shine on this surface, it's going to produce this circular shape. So let's bring back this circle to the empty. Now if we go to the render view, we should see that circle. Okay, let me make this visible sun, and see it is producing that shape. And now if I change this circle to something like square, let me change this to vector. Now we have square, we have this square shape of the caustics. And if we change this to something like heart, let's also make slightly big. Now if we go to the render view, you can see that the shape something like heart, but it's not correct. The reason for this is, so if we go to this side view, we can see that this plane, which is a screen, is blocking some of the light from this sun. So that's why we are not getting the exact shape of this heart. So to get the exact shape of this heart, what we have to do is either we have to slightly rotate this our light source, and then the focus will shift to in this direction, and then we can put the plane there and get the correct shape of the heart. This is not the good way to do that. So best thing is we first put this this deformed shape as well as this heart into a separate collection, then use that instance of that collection for the final rendering, which is more easy to handle according to the orientation of this screen as well as the light source. So, and also we don't need that projected curve here, so let me delete this and just connect this. Okay, so let's put this plane into a separate collection. So let's add a new collection, and I'm going to rename this as a mirror, and let's bring this Bezier circle empty as well as that plane into this collection, and let's disable this. Okay, now let's add that instance of that collection. Now we have this, and now let's rotate this by this angle. And another thing I would like to mention here is that this is basically the principle of this mirror. So if you rotate the mirror by some angle space theta, let me bring the annotations. So this is the light source and this is the mirror. So this is the line which is joining the normal to this light source. Now if you rotate this mirror by some angle, say something like this, so this is the new direction of the normal from this mirror, and then this ray which is here, it going to pointing something like this. Okay, something like this, and this is also angle with the theta. So basically the image is going to shifted by 2 theta if you rotate this mirror by an angle theta. So keep in mind that. So because we have rotate our this deform plane by -5 degree, then we have to shift this screen at 10 degree based on that principle of the reflection of the mirror. So now let's go to the render view, not at the correct angle. So let me change it to slightly something like this. Now we can see that we have a proper heart shape. Let me increase gain of the sun so that we can see more caustics. Another thing which is also important here, the whole mesh is contributing or deforming according to the shape of this heart, but we want only a certain part of this mesh is deformed according to this shape. So which is important when you want to deform only some area of an object like a ring, means front part of the ring. So for that, so we're going to use vertex fade to mask that area. Change this to object mode, and now let's bring that weight here, mask, and let's go to the modifier, add this to group, and now if I directly plug that into the selection, we can see that only this portion of this mesh is deforming according to this heart shaped. You can see that heart shape. You can also smooth this, which I have shown in my finished project file. So this is it for this tutorial. You can download the finished project file, which I have made a clean note tree so that you can directly use in your production with a smooth transition for these vertices. If you like this work, then please do support me on my Patreon page, and like and share this video and subscribe to my channel for more updates. So until next time, happy noding. Bye.